You can do that, but at some point in time, you have to ask yourself, is that what you want in your academic life? If you want more, you have to go beyond that. But unfortunately, no, this doesn't really shine yet. It only shines here, not here. Applying research for understanding phenomena or determining causality. Most practitioners seek this to solve their problems or to frame strategies. Even managers do that. I have been to more than 1,000 firms from end to end. Managers still do that. They also actively study, read to solve problems in firms. It's not just about hiring people to solve problems. They are still learning all the time. Remember, knowledge is a dynamic concept as opposed to information. If you have a learning mind, if you evolve a learning mind, you're always reflecting, thinking whether this makes sense, and then in the process, you go and seek explicit knowledge, embodied in books, manuals, or even talk to others, but you can also seek tacit knowledge from people with experience who are there doing things. And it's easier now with the web in place. You can surf the web and find many things. You can even interact with people. Unfortunately, most academic in developing countries, unfortunately, have gravitated to using Western frameworks. In other words, more often than not, they just look at this as the framework that's most ideal. They use it to see whether the evidence in their own country or set of countries follow that sort of conjectures. Now, that's in the past wasn't accepted by the Ivy League universities and the big ones, including Cambridge and Oxford, but now, for a long time, because the interest is finishing, because if you don't finish your PhD, you have a backlog for others there, not only others in the stream, but also it's sending the wrong signals to potential students. It's a bit like how martial arts, the black belt those days in karate and judo. Those days, unless you had a special move or you broke the arm of the tester, you get a black belt. Now everybody goes through that in 3 years. In 3 years, you go out and the next batch of students come because commercialization has gone everywhere, including here. Now here you have, you can stop me at any time, please. If you think I don't make sense, or if you think some things require clarification. Now you have exploratory research, although most of the time the excuse used to study taking that approach is not rational, simply because people haven't studied enough. Remember that when you are trying to establish a statement of problem, or you problematize your statement, where you need to establish why it's worth studying, what's the scientific value of it, what's the societal contribution to it. Once you've done that, you come up with research questions, because you know that there are shortcomings that is worth studying, society will benefit, advance scientific knowledge. Then you go and look at the literature that deals with it, the peers in that area. Now in the process, you have to unbundle and find all sorts of shortcomings here. If you cannot find any shortcomings in their work, whether the conceptualization was wrong, whether the data they used was not representative, whether there wasn't sufficiently long series to establish causality, whatever it may be, unless you find gaps of that sort, you don't have a new research, because you have the solution already. So you need to establish that. Now, the exploratory part is an excuse often students use because they haven't really read so much. I found a lot of my students say, well, nobody has done this study. Only because the student hasn't really studied enough. But indeed, some cases, there will be times when you won't be able to see any. No such studies exist. Then yes, you justify and you take an inductive approach. You go to the evidence first. But in the process of going to evidence, inductive is not the way you see it in the textbook, in a dictionary. In a dictionary, inductive means doing something completely different, unconnected to other forms of work. No examples to follow. A bit like theory. If you go to the dictionary, it says something abstract that is not practical. You go and check the dictionary. But to a social scientist like me, a theory comprises of a set of propositions that are parsimonious, where you can extract those propositions and test them. That's a theory. And they hold until you find evidence to refute them. Is there a clock or something so I can time myself? Now, if you don't have that sort of thing, only because you don't have past to work with. Then, of course, you are going to take an inductive approach, and you need to work with open-ended questions first, because you don't know how to frame this. But remember, in reality, you will follow other examples of how such studies were done, so that it provides you some kind of a path that may not be clear, but at least a path for you to go. It's a bit like the Chinese proverb. When you are crossing a river, you look for areas that are closer to the stones and so on, so that you can reach and cross. That's the proverb behind. So likewise, inductive research is often done that way, through trial and error. Descriptive, this is very much ontological, meaning you're collecting anthologies and so on. Explanatory, here you need to explain, which is deductive. You take a set of propositions, you design a questionnaire. You can often have closed-ended questionnaires there, or even establish like-a-scale scores, which will have to be in odd numbers, like a scale score. The most popularly used one is 5. 1 to 5, sometimes 7, sometimes 9, sometimes because of the nature of the data can also be 3. It's different from a dummy. A dummy is 0 and 1. Prescriptive, you are working on a strategy, on a research that at the same time requires you with the purpose of encouraging a direction already. Most of the time policy strategies use that. Proscriptive, this is the point that you build a certain set of assumptions with evidence from the past, and that guides you. Bhagwati often mentioned that because governments have intervened expansively in the past, you cannot just liberalize economies because of the huge amount of market failure that was already around. So you need to provide incentives to undo those negative practices of government before. That's proscriptive. In other words, you are in both deductive and inductive, you are at the same time following a certain line of thinking that assumes a past that has been complicated by conduct of active agents then, in this case the state. Action-oriented, this you become a participant, the example I gave you on, say, identifying and checking crime, or even drug addiction or alcoholism, whatever you think is socially a deviant behavior, you need to correct. Now diagrammatically I'm putting it up there, what I explained earlier. This is initiating research. Concept and philosophy as the driver of research and the determinant of methodology to be used. Ontological and epistemological research. I think I can go straight away to this one, because this explains the same thing. You begin with a problem statement, you problematize first. Problematization is a process where you do research to explain why that particular topic or that particular research is important, and what sort of scientific knowledge you're going to advance in the process of doing it, in what way society can benefit from your research. Then you must also explain whether it's doable. I can give you an example. I gave this keynote when the Sustainable Development Program was launched at Cambridge in 2016. I went to stay at Cornwall and Key's College. I saw a big banner with Stephen Hawking. He was saying that humankind has about 600 years left. Immediately they attracted me. Dunia kiamat, end of the world, doomsday. 600 years left. So I went to closer and read the whole thing. He says that despite all these efforts that we are doing here, with Nobel winning the Nobel Prize now, and others like Nicholas Stern, he says this world is doomed because of the sort of things we have done. Now, of course, he's dead now, and not many believe in what he has said. He says in between 65 to 100 years, we should make an effort to find a new planet to live. And he says the technologies then will allow us to move to Mars. He says it's really possible to move to Mars. And remember, he says it takes 20 years to reach there from Earth. It takes 20 years to reach there, he says. That means if you are 20 now, if you're boarding the ship, how many of us can go in a spaceship? For you, you'll become 40 by the time you get there. Actually, scientists are willing to go. It's like the way Christopher Columbus, when they were going to the West, the feeling then was the Earth was like that, as a box. You would just collect that side. But the scientists were confident that it wasn't the case. So they were willing to go, taking the risk. Now likewise, the scientists are willing to go if we are willing to take them along. But the US has now launched another spaceship, I think a few years ago, with robots now, smart robots. So they may be able to say more. But Stephen Hawking also discussed that in future, humans may be able, if only science advances the way he wants it to advance, humans may be able to go, you buy a ticket as a tourist, you fly to Pluto. Now people are not accepting Pluto as a planet anymore. It's planet 9 now. Then you exit to a next solar system. Now I don't know whether that will be our greatest generation's, not conceivable. It looks like it's exciting. Society will benefit, but is it doable? At this time, it doesn't look like it's doable. Even if you invest 100 billion, not million, euros, doesn't look, it's like throwing money into the ocean now. So it's not doable. So you need a simple example of what is not doable is, you want to study how technical change takes place in a firm, how production organization is done, how the imposition of just-in-time, for example, or cellular manufacturing has impacted. Now, if you want to go inside the firm, you need to have the ability to get in. Most of us don't seem to have that ability. I have had students who had to help give that and make that access. Otherwise, you have this nice idea, but you don't get into any firm. That again, if it's not doable, not worth sitting there for 3 years looking to get into a firm. Now, in that process, if you are doing ontological, you collect ontologies and so on, you come up this way. And then you have results, and epistemological hypothesis, and testing with empirical data. And then you also come up with these results and analysis, and then conclusions and implications. The problem I find in most of the students that I try to drive them to do is, most of them tend to just accept existing works. They review, well, this is what these guys say, I follow this. I think the more robust way is to see whether the approaches taken by them, the example they've used, the data they have amassed, are rationally, to you, make sense. Because if you can identify there are lots of gaps with it, that's a superior way of doing, not just a PhD, but research on your own, in order to be able to access the journal. But remember that it's not necessarily a work that you think is superior gets into a journal. Let me give you an example. If you go and look at the Scandinavian Journal of Economics, there's one issue, I forgot the issue, 1992 issue, where Nobel laureates and potential Nobel laureates were asked this question. Ronald Coase, when he was asked, did you have any problem publishing? He said no. Oh, you must have had an easy time. You're lucky. He said no, I was lucky because the editors told me to send the papers. He had no question, they were just published. Ronald Coase had very few citations until he won the Nobel Prize, 1991. This is every of his work comes from his 1937 article, The Nature of the Firm, where he explains why firms exist, using non-market ways of why market failure leads to all this reliance on trust and other forms of institutions. He defines institutions that way. Now, Krugman was asked the same question. He wasn't a Nobel laureate yet then. He said, as I read this article, or letter, I have a paper rejected on my table. And he says that the best papers to me were rejected first. But his explanation for them was, I believe the referees didn't understand them. He didn't use examples like, because it doesn't look nice if you say, well, your line of thinking was different, which is also likely, or you don't follow a certain set of rules which they require. Some journals too, my students have reported, and I've seen this true, you don't have enough citations of their own journal articles, they write to you, well, our readers won't be interested because your work doesn't seem to be in sync with what we do. But that's the indirect way of telling you to quote their own papers. Now, you don't have to worry about those things if you are serious. But at this time, you should at least have some. Otherwise, it will have a bearing on your confidence. I come back with the same thing that I explained to you just now. You begin with a problem, statement of problem, extract research questions, then you go and read what the peers are doing. After which, if you are taking the approach of epistemological approach, hypothesis, you frame your hypothesis based on the evidence you've had. Then you come up with a research design. Sometimes the data is already available based on secondary data. Sometimes it requires collecting the information. Sources and methods for collecting and coding the data. If you are into primary research, it's not as simple as simply just sending a questionnaire and just, you may have a response rate that is very low when you send questionnaires. And remember the Cronbus alpha statistics requirement for sample validity, it might be at least, some people accept 60%, but normally it's about 70%. Do you need to follow that sort of procedure? There are different techniques to avoid that too. But that is not enough. If you are immersed in research the way I've done fieldwork in almost all the continents because of the World Bank, UNIDO and so on. Now, more often than not, the responses are not right. Coding requires going back to them when things don't make sense. It's not just statistically you take the outliers away, which is what many of them do. It's a bit like, many of you tend to use variance inflation factor to see multicollinearity. But the best way, the way I did econometrics many years ago, is to do stepwise regression to see if the dropping of one variable significantly affects the coefficients of the other variables. Variance infrastructure actually doesn't really do that, but most journals carry that now. Now I'm just giving you examples of these things. So you can move on that way and then you come here. But this is how research is driven, from this side to the other end. Some of you, because you simply, I had a student called Chia Yong Kang, the senior lecturer at University of Uttara Malaysia now. He starts around here because he loves statistical methods. He likes all this Granger probability tests and so on. Everything he does must have panel data. So you can't suddenly tell him, oh, there's a gown project here. They want to know why a set of people don't have the awareness in relation to the kind of diet they are into. Then he's lost there because he hasn't developed the ability to design a methodology that's suitable for them. Okay, we are less than half an hour now. So I need to finish quickly. I'm halfway at least. I already mentioned this to you, so I don't have to go back there. But there's also qualitative, empirical and non-empirical work. Sometimes an example of a guy, but you can provide empirical work each time you want. Like Chang Ha-jun, the professor at Cambridge, or Eric Reiners, or even Ostrom and others, the recent Nobel laureates. They make an argument, all they do is to provide some evidence in the way Adam Smith did it in the past, the way Alfred Marshall did in the past. They were inductive in this, they make an argument, they have a set of evidence. You don't need to have a series as such. Just to back up your point, that some of them reject that sort of use, but it's not universally accepted principle that you must have a huge, large data set as such. It's a bit like big data analytics. Anybody working on big data analytics? Now I was completely confused, and I took a student from big data analytics. He himself confused me even more until because I'm doing research on Industry 4.0 now. I'm with Professor Ulong grant, 300,000 for distinguished professor grant that was given. Now, big data analytics actually, if you are say dealing with diagnosing a patient on something, now the robot is capable of only gathering data about you from the broad. It learns first from the broad this thing, how to diagnose say a neuro problem or something. It actually learns from the previous prescription diagnosis and so on, and then comes and picks up that data from your entire data set series, and then provides the diagnosis. And then there's another robot to follow the diagnosis and operate keyhole surgery. Now that, in other words, it's not about getting a huge data set as such. For each one of these problems, it's selective in that sense. Whatever is available, the robot is capable of doing, including the work William Nordhaus, the guy shared the Nobel Prize this year with Paul Romer. He also uses a robot because they handle a massive amount of data for the projections they make on climate change. But again, you can also convert qualitative data to quantitative data using large scale scores. But you must be very careful, otherwise you will bias your estimates. We don't go to examples here. Data collection. Seek representative sample of population. I find that many students don't seem to gather the basics of it. I still stick on with the rule that if you don't have time series